Welcome to In the Shop, a video series that aims to help CNC machine operators overcome challenges routinely encountered on the shop floor. I'm your host, Kevis Mitchell. In this episode of In the Shop, we're going to go deeper into the world of tool and cutter grinding. Today, we will be discussing coolant. The words coolant and grinding fluid are often used interchangeably because they are the same thing. Coolant is one of the most critical consumables used in the grinding process. As the abrasive compounds in the grinding wheel removes material from the workpiece, temperature builds. And if the temperature doesn't stay within the tolerance threshold, you could risk creating parts that fall out of spec. Essentially, coolant helps ensure you've got a stable thermal system in which to execute your grind. We're here today with Tom Cappadona from Blaser Swiss Lube, one of the leading manufacturers in our industry. Tom, what do you have for us today?
Well, the purpose of the coolant is to keep the part cool and to flush out the chips during the grinding process. There's two different types of coolant or grinding fluids, as you pointed out. There's oil and there's water miscible. Oil does a great job because of the lubricity of keeping the part cool during the grind. Water miscible, on the other hand, does a great job of taking the heat away from the part. Typically used in tool and cutter grinding is oil.
So Tom, what else can you tell us about coolant in the grinding process?
Well, what's important is to have a good base oil. You need to have either hydrocracked oil, a gas to liquid, or a PAO. The flash point is obviously going to be important as well. The purer the oil, the lower the flash point. Flash point is where the smoke turns into flames and you can have fire.
That would be a bad thing.
That's a really bad thing. Also important is the part material. If carbide is going to be ground, then you have to take into consideration the possibility of cobalt leaching, and a cobalt additive can be added. Also the part diameter.
So what are some of the other considerations people should consider when selecting their coolant?
Lubricity. Obviously, the more lubricity you have, the longer the wheel life. It's a trade-off though, because if you have too much lubricity, then the wheel will actually not break down and self-sharpen, which is what you're looking for. Also, the formulation of the coolant has to have the correct additives and base oil for the application.
So Tom, is there something that should cue in an operator when they should replace their coolant? And what's the life expectancy of the different types of coolant?
A modern oil will last 10 to 15 years. We can test that coolant in our laboratory up in Goshen, New York at our headquarters for the qualities that are necessary. Those qualities are like the viscosity. If the viscosity starts creeping up, there's a good possibility the tramp oil is getting in way lube, that kind of thing. Also the level of cobalt, we mentioned that before, but it's a health and safety issue for the operator. Also water, if water gets into the oil, it can promote bacteria and give a bad smell. It can also create corrosion, which obviously we don't want a beautiful machine having corrosion on it.
I definitely don't want that bad smell.
And if you take all those things into consideration, that's why we consider the cutting fluid or the grinding fluid or the oil our liquid tool.
Thank you very much, Tom. We're going to be seeing you around. We're going to head over to our Solution Center. We're going to talk to Hans Klaus, one of our applications engineers. We're going to get more information about how we use coolant in our grinding process. Hi Hans, what are you going to show us today?
Today we're going to be looking at how altered machines deliver and assign coolant during the grinding process.
Okay, so that sounds great. What are all of these things here?
These are all different kinds of coolant lines that we can install on the machine. We have a modular plastic line, usually for low pressures, 6 bar, around 90, 100 PSI. These are really flexible, especially for changing on the fly.
Right.
These swivel nozzles can be used in mostly the same way, except you can tighten them down with threads and they're a lot more rigid. So if you're using higher pressures, this is the most flexible option. And then depending if you're using a wheel changer or maybe you have standard wheel packs,
Right.
Something like this where you have a solid stainless steel pipe where you can put it exactly at the same contact points over and over again in a job shop, and it's a very standard practice to set up on the machine.
So Hans, do all of these coolant lines have different pressure ratings?
They do. And when you do purchase them, it will say up to 6 bar or 90 PSI or something like that. The plastic are going to be the weaker ones. Once the ball joints start to wear out, these are going to be moving once the pressure is being administered. And so we don't want these to move. So if you're using high pressure, we can't really use the lock lines. That's why we use the other two. We use the swivel nozzles and we use the solid piping, not only for consistency and ease of setup, but also because if you get to a 20 or a 40 bar option that Walter provides,
Right.
You're going to need something more rigid.
So can you share some of the best practices on placement of the coolant nozzles in the machine grinding process?
Yeah, so I really think, people ask about coolant all the time and it may be an overlooked subject, but really the important thing is to understand a little bit about how the grinding wheels operate, a little bit about how the materials, especially the depth of cut, things like that, but most importantly, where on the grinding wheel are you going to be contacting? Where is the hot point? Now, I can go into Tool Studio and our software will show exactly where on the wheel that we're going to be grinding, so that's very important. If you're using something like a 1A1 or a 1V1, we're going to want as much coolant going to that exact point on the bottom of the wheel. If we have a cup wheel, for example, well, maybe we will do an outside diameter clearance at 90 degrees, but then we might have to do an end phase clearance at 0 degrees.
Right.
So now we have to think about the process, and we have to put the coolant lines exactly where they need to be without obstruction, but as close as possible to the wheel as we can.
So how much coolant is getting to the point of contact in an average coolant nozzle operation?
Sure. Even under good conditions, as little or as much as 10%.
10%?
About 10%.
That's
because,
it?
Yeah, because really the wheel is spinning at, let's say, 2,000 RPM.
Right.
It creates slight turbulence on the periphery
Wait a
of the
minute,
wheel.
turbulence?
Somewhat. There is some turbulence if
So
the
like
wheel...
aircraft turbulence?
To a degree. On the periphery of the wheel, if the coolant is too far away and the nozzle is spraying, air molecules get introduced, it creates misting, and then that turbulence on the wheel is just going to shoot it out, and very little coolant will actually get to the hot point. We need to maintain pressure and as much flow as we can only to that hot point. That's what's important. We need to maintain temperature, and we need to flood out the chips. So as soon as the chips are taken out with the diamond, they go into the pore of the wheel. We need to flush that away as quick as possible.
Thanks a lot, Hans. King on the best practices about filtration. Let's go to Fred Poppe and learn more about grinding fluid.
Thanks, Kevis. What are the advantages of clean coolant and temperature control? To begin with, clean coolant provides extended fluid life, provides wheel life and extended tool life, provides a consistent process that will allow today's manufacturing of tight tolerant parts. It also helps for a more efficient manufacturing and higher production rate, which leads into better fit and finish, less part rejection, and allows you to keep your machines clean, which reduces maintenance, along with premature wear on any moving parts in the machine tool. Next is temperature control and stability. Temperature control, once again, provides consistent part manufacturing of today's precision products, eliminates costly setup times, machine tool adjustments, and allows for tight tolerance manufacturing down to 1/4 degree Fahrenheit, which in turn decreases cycle times, maintenance, and downtime. This also extends the fluid life. Carbide recycling. With today's technology, backwash systems that are offered seem to make the most sense for carbide collection. Today's filtration systems are more advanced than ever, with temperature control down to 1/4 degree Fahrenheit once again, and micron levels of filtration down to 1/2 micron. It just makes sense to remove all the carbide from the machine tools and the filtration and get the most money for your carbide sludge. By keeping the carbide suspended and forced over to the suction of the filter pump, this allows you to eliminate such things as cobalt leaching, downtime for cleaning the tank, part rejection, and extends the wheel life. Now available in the backwash system is bulk drum collection, where it can be stored in minimal space. Recovery of this material makes more sense than ever. Along with the ability to change the drums during operation, you can maximize your time and get the most return on your investment. Pre-filter options. Today's pre-filter options, most common pre-filter options, is the magnetic separator. This will remove most of the material prior to the final filters. It removes all magnetic material. For non-magnetic material, you have the secondary is the bag filter. This is a pressurized bag filter that collects all the material such as silicon, ceramics, and non-magnetic stainless steel. This eliminates and extends the main filter life. Last but not least is a standard gravity bag filters. This will give you pump protection and minimal collection. This will keep all the material from going into the pump, extending pump life. That's it for clean coolant, temperature stability. Now let's send it back to Kevis.
Thanks, Fred, and thank you everybody else. Hey, we'll see you guys next time on In the Shop.